So this is a mini lecture on continental rifting. So it's continuing the lecture that I did on mid-ocean ridges. Okay. So Keary, Kleypas and Fine is a good textbook to look at for this section, and there's a whole chapter on continental rifts in chapter 7 of Keary, Kleypas and Fine. So, to create an ocean basin, we first of all have to rift a bit of continent, and to create a break in the continent to start creating oceanic crust and oceanic lithosphere. And so to obviously start the process of oceanic spreading, we need to create these rifts. And we can see that this occurring on the Earth in a number of places to get today. So, for instance, here, this is the Arabian Peninsula. Here, Yemen is over here. And at the moment, the Arabian Peninsula is moving off in this direction. We can tell that relative to Africa from the transform faults in here. So we know that this is moving in this direction relative to Africa. So we can draw on these vectors in which the relative plate motions between Africa and the Arabian Peninsula. And it turns out that it's moving faster out here than it is up here, which means that this bit of Africa is being pushed off in this direction, and we're getting a rift valley forming down here. And this is the East African Rift Valley, and we see volcanoes developing in this rift system. So if we look down the Rift Valley, so this is looking down the Rift Valley towards the southwest, we see scarp slopes on the sides of the Rift Valley, and within the rift, then a flat area in the bottom of the Rift Valley where we see some volcanoes developing through from melt coming up from from depth. Okay. So if we look at a map of this area with some vectors plotted on it of the displacements, you can see that Africa, this part of Africa is moving 10 millimeters per year in this direction, but the Arabian Peninsula is moving 30 millimeters a year in this direction. So we're accommodating that by extension of the Red Sea at about 16 millimeters per year, but then we've got extension of the Gulf of Aden of about 23 millimeters per year, which then those sum up to have an extension across the East African Rift of between 6 and 7 millimeters per year. So we're opening up this rift system in here. Okay, you can see it's more complex than just a simple rift valley. We've got this rift in here, and then over here we've got this other the western rift over here. And if we look at some cross sections, so these are a load of cross sections. So for instance, this cross section this should be labelled B through here. Is through here. This cross section is through here. This cross section is through here, and this cross section is through here. And what you can see is that all of the rift systems are asymmetrical. So we only have a fault on one side of the valley. So we have this normal fault in here. We've got this normal fault on the western side in this case, whereas on this one here, the rift, the fault is on the eastern side, and so we have this sort of asymmetry developed. In this case, we have a fault on both sides, but the fault on the west side has got more displacement than the one on the east side, and this is part of the process of forming a rift. So if we think about how a rifting event forms, so we start off with a normal piece of of continental crust, and for whatever reason we start to generate some heat below the lithosphere. So the asthenosphere starts to rise, causing this increase in heat in here, and we get some early volcanism developed in there. This heat rising causes the lithosphere, the asthenosphere, to rise up. So we get a rise in the asthenosphere. This heating of this material makes it less dense, so we get isostatic uplift due to this increase in temperature in here, so thermal expansion. So we get a uplift in here. Okay, so we get this doming of the crust. Okay, and that puts the outer part of the crust into tension. So because we're doming it over, we're stretching along this layer, so it puts it into tension, and that causes extensional faults to develop. And so we start to extend this crust, and we form a normal fault, and we end up with this sort of asymmetric picture. And that's where we're at in the East African rift in some places. So we've got an asymmetric, so a rift valley with only one fault on the side of it. Okay. This fault forms where you've got the maximum curvature, and when we generate a fault here, and then we get a second fault developing over here where we've got this subsequent point of maximum curvature, and we end up with an established rift valley, and we start to fill this rift valley with volcanic deposits, and we start putting sediments into here, and this periodically gets flooded and by seawater, and then we get evaporation, and we get evaporites forming as well in this stage. Okay. And we get continued extension. So this starts to we get the extensive front spreading away from the main rift valley. So we generate a number of these normal faults dipping inwards towards the center of the rift valley of the continental rift. Eventually, we generate enough amount of extension that we start to begin to generate oceanic crust in here. Okay. And we have we make new ocean floor in here, and this is a bit like the Red Sea at the moment. Okay, and we get proper marine sedimentation and volcanism occurring at this stage. If we continue further, we start to have the two continental margins diverging, and we get the formation of a passive continental margin on either side of the ocean basin that is going. Okay. Also associated with this, as we move away from the rift, this is cooling as the asthenosphere descends deeper as we're moving away from the heat source. And so we get thermal subsidence associated with that. So we get a sort of a rise in sea level as this moves away. So at this stage we've established these passive continental margins, and we've generated a new ocean in here. So if we look at the sort of main characteristics of these continental rifts, so we've got this graben structure, this rift structure where we've got faults dipping inward towards the centre of the rift, with volcanic material being deposited in here, mostly alkaline magmas. And then we have a number of these normal faults as we move away from the centre. Okay, and we have steep slopes, steep fault scarps, which you can see in the East African Rift, created by these normal faults. Okay. We've got, and this is caused by the raising of the asthenosphere below the rift. Okay, which causes uplift, so long wavelength doming of the crust due to this higher temperature, lower density material that is below the rift, causing isostatic uplift, and so to be in gravitational equilibrium, this has to uplift. Okay, and so if you looked at the gravity above here, you would see that there would be a gravity low above the rift valley due to this lower density material below the rift valley. And the raising of the asthenosphere is thinning the lithosphere, and then the stretching that is associated with it is further stretching the continental crust part of the lithosphere.